This video I am going to go over how you draw ionic and covalent bonds using Lewis dot diagrams. So first I will start with ionic. Remember, ionic bonds are bonds that involve a transferring of electrons. So anytime you have electrons being transferred, you are going to get positive charges, which are cations, and negative charges that are anions. And then those cations and anions basically stick together because they have different charges. So follow along with the periodic table. And fluorine is a halogen. It has 7 valence electrons. Now, alkali metals will, or any metal, is going to transfer its electron to the non-metal, and then that's how they're going to end up achieving their stable full valence shell of electrons, that stable noble gas configuration. So lithium is going to transfer the electron to fluorine, and now what you end up getting is lithium, that's a positive 1 charge, and fluorine, that's a negative 1 charge. And since you have 1 lithium and 1 fluorine, you get something like LiF. Now let's just say keep working with lithium again. That has 1 valence electron. Now look at your periodic table. Let's say it's going to bond to sulfur, for example. Sulfur has 6 valence electrons. Now, 1 lithium will be able to give an electron to that sulfur. Sulfur still will not have 8 valence electrons at this point. So what we actually need is another lithium to transfer another electron to that. So now what you get is a lithium that's a +1, that's coming from this one. This lithium ends up with a +1, and there's only 1 sulfur there needed. And since that gained 2 electrons, that has a -2. And what you end up doing is, since there's 2 lithiums, you'd write Li2S. And this is how you do it when you're showing ionic bonding with Lewis dot diagrams. Now let's say we're going to work with something like aluminum. Aluminum has 3 valence electrons. And then say that's going to bond to something like nitrogen. Nitrogen has 5 valence electrons. So what happens is the aluminum can donate those 3 electrons to the nitrogen. So now aluminum, since it got rid of 3 electrons, is a +3. Nitrogen's a -3. And notice how you have 1 of each. That becomes AlN. Now, let's say we're working with magnesium. We'll just draw it as 2 valence electrons there and say that is going to bond to chlorine. Chlorine has 7. Oh, I put 1 too many there. All right, chlorine has 7. So this magnesium can donate 1 to that chlorine. There's not enough room around that chlorine to get another one now, because now this chlorine has 8 valence electrons, and that's as many as it can hold. So we need another chlorine here. I'm just going to draw these dots slightly different. All right, still 7 valence electrons. So we need another chlorine there to get that other valence electron. -1. So what you end up getting is MgCl2. So that's how you would do this for ionic bonding. You show how many valence electrons they have, where the electron are being transferred. So in this case, it's going from the lithium to the sulfur, or in here, you're going from the aluminum to the nitrogen. So you're always going from the metal to the non-metal. You show the resultant charges after those electrons are transferred. And remember, if more than 1 electron is transferred, you end up with a +2 charge in this case for magnesium, or in the case of sulfur, 2 were transferred to the sulfur, so you got a -2 charge. And aluminum got rid of 3, so that's positive 3, and nitrogen gained 3, so that's negative 3. So you have to keep track of all of those electrons. So now that was ionic bonding. Now we're going to do covalent bonding. Covalent has to do with a sharing of electrons. So what you want to do is write down, so say I'm working with, this is carbon tetrachloride. You want to put down the one that will make the most bonds first. So carbon, since it has 4 valence electrons, I'm going to put that in the middle because that's going to make 4 different bonds. Now chlorine, I'm going to draw this in a different color. There's 4 chlorines that I have to put in here, and they all have 7 valence electrons. All right, now what happens is these electrons here get shared. So I'm going to put a little circle around them just to show that they're the ones that are shared. And what you end up getting is C, and instead of having all of those dots, I'm going to simplify it. These dots that are shared, these electrons that are shared now become a dash. And I'm going to redraw this structure, but when you do this, remember to put in the unshared pair of electrons around chlorine. So the dashes here count as these shared pair. And then the unshared pair are these pair around chlorine. Remember, I keep saying pair. They're unshared pairs. There's 2 of them there. So now when we look at this structure, you should be able to count up the valence electrons for all of these elements. So if we look at the carbon, for example, with the electrons it's sharing with chlorine, it should have 8 valence electrons. 2 are coming from that dash, well, from each dash, right? Because you have 2, 2, 2, 2. So you count the dashes as 2. 2, 4, 6, 8. Now around each chlorine, there should be 8. The dash counts as 2. It counts as 2 for both the carbon and the chlorine because those electrons are shared between those elements. So you have 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. For any bonding that we do, every element is going to end up getting that octet, 8 valence electrons, with the exception of hydrogen. So let's say we were going to work with just water, H2O. Oxygen has 6 valence electrons, so I'm going to put that in the middle. Hydrogen has 1. Right, so these are the bonds that are going to be shared. So when you draw this, put in those unshared pair again for around oxygen, draw the lines for hydrogen, and now when we count this up, since hydrogen only has 1 energy level, it can only hold at most 2 electrons. So this hydrogen has 2, that hydrogen has 2, so it's fulfilled. Now this oxygen has 2, 4, 6, 8. You're not always going to need to put in unshared pair of electrons, only where they're necessary. So in this case, the hydrogen doesn't get any. Now if we have something like methane, put the carbon in first, 4 valence electrons, and then we put in the hydrogen. I'll use a different color. So now what we end up getting is carbon bonded to those 4 hydrogens. When we do it this way, the carbon has 8 valence electrons because each line counts as 2, right? Because these shared. So 2, 4, 6, 8. Each hydrogen only gets 2. Now there is the possibility of getting double bonds or triple bonds. So if you have, for example, CO2. So we put carbon in the middle because that's going to make the most bonds. Now we have 2 oxygens. Well, you know what? I'm going to draw this a little different just to make it a little easier. Oxygen has 6 valence electrons, so I'm going to draw them over here. And then this oxygen has 6 valence electrons. So we're going to get some bonds formed here. You're going to get these electrons shared, and these are shared between this oxygen and this carbon. These get shared, and I should have drew this a little different, and those get shared. So what we end up getting is carbon in the middle. these two bonds are forming a double bond between that oxygen. Put in the lone pair again around oxygen, the 2 lone pair. Now this carbon and this oxygen, they have 2 bonds, that's a double bond. Put in the oxygen, put in the 2 unshared pair. So now on this carbon you have 2, 4, 6, 8, because remember each dash counts as 2 electrons. So this carbon has its octet fold. Oxygen has 2, 4, 6, 8. Over here this oxygen has 2, 4, 6, 8. Remember the dashes count as 2 because they're being shared. And you can also end up getting a triple bond. So let's say you have something like N2. You have nitrogen with 5 valence electrons. And then we have another nitrogen with 5 valence electrons. And what we end up getting is these get shared, these electrons get shared, and these electrons get shared. So now you have 3 pair of shared electrons, which means 3 dashes. Remember to put in these unshared pair again, and the octet will be fulfilled. For this nitrogen, you have 2, 4, 6, 8. For this nitrogen, you have 2, 4, 6, 8. All right, so that is for covalent bonding. Remember, there is a difference. Covalent bonding is sharing, so you're not getting charges. Electrons are shared. For ionic, they are being shared, so you get charges, positives and negatives, and then those positives and negatives are attracted. Just remember, for ionic, you have to keep track of how many valence electrons each element has, so you might need more of one element than another.